Hey everybody, let's check out the writing equations of a tangent line video. This is an extension of the video where we just found the slope of a graph at a specific point. First thing we'll do is we'll take the first derivative, substitute our x value from the point given into our derivative, (3 times -2 squared plus 1 is equal to 13. We have just found the slope of the function at the point -2, -7. In order to write the equation of the tangent line, we're going to use that slope and the point given. And we'll have a little flashback from college algebra, point slope formula. It's that really long one that you had to use quite a bit in college algebra. We're going to do y minus -7 with the substitution there equals 13 times x minus -2. If you want to go ahead and call those +7 and +2, that's fine. Just be careful with your signs whenever you're working these problems. We're going to get y plus 7 equals 13 times x plus 2. Distribute 13. Subtract 7 from both sides. 26 minus 7. And that gives us our tangent line. The second example, basically the same technique. We just changed up functions and point. This function will be a little easier to work with if we write 3x plus 1 twice and FOIL. Just to write it in an expanded instead of a compact form. 3x plus 1 times another 3x plus 1, FOILed out. Now we take the derivative. Substitute the x value from the point given into this derivative. And that gives us a slope of 6. Like we did on the last example, we'll recognize 6 as our slope, 0, 1 as our x1, y1. And then we'll have y minus y1 equals m times x minus x1. Distribute the 6. Add 1. And we have the equation of the tangent line we were after. Very good. On our last example, we're going to determine the points at which the graph of the function has a horizontal tangent line. A graph has a horizontal tangent line whenever its derivative or rate of change is 0. At the top of a hill or bottom of a valley, there is no rate of change, it's 0. So basically what we're going to do for this type of problem is we're going to find our first derivative and set it equal to 0. That way it has a 0. Remember that horizontal lines always had a 0 slope. So just remember for that, we're going to set our first derivative equal to 0. For this function, our first derivative is 4x cubed minus 4x, and we're going to set that equal to 0. We want to know where the rate of change is 0. The derivative you can factor out of 4x. If you factor out a 4x, you will have x squared minus 1 left in the parentheses. X squared minus 1 is a difference of 2 squares, and so it'll factor as x plus 1, x minus 1. Setting each factor equal to 0, we're going to get values of x that are 0, negative 1, and positive 1. Since we're asked to determine the points on the original function's graph, we're going to substitute these three x values back into the original function. Okay, so our original function is x to the 4th minus 2x squared plus 4. If you replace the x's with 0, your answer will be 4. That gives us the point 0, 4. If you replace all the x's with negative 1, negative 1 to the 4th minus 2 times negative 1 squared plus 4, you will find your answer is 3, giving us the point negative 1, 3. And then finally, f of positive 1 also gives us 3, and that gives us the point 1, 3. When you enter your answer on WebAssign, it will ask you to list these with the x values going smallest to largest. So you just be careful when you enter. You'd actually want to put the point negative 1, 3 in first, 0, 4 in second, and then finally positive 1, 3 in third. And that's, again, just because it's you're asked to order it.